So this was the second question, exercise 6.3, right? Okay. So they are saying that in the figure, triangle ODC and OBA, they are similar. ODC and OBA. Okay, they are similar triangles. Then what else? Angle BOC is 125 degree. This angle is 125, okay. And CDO is 70. CDO, okay. It's already mentioned over there. Then find DOC. DOC. So this should be straightforward, no? This is a straight line, Tanushri. This
Yes,
angle
sir.
is 125. What will be angle DOC? How can we find it?
180 minus 120.
Yes, two are linear pair, right? So we can easily find 180 minus 125, no? So this is linear pair. Right, Tanushri, you know that, right? If this angle is 125, the other linear pair, so you can do 180 minus 125.
125. Yes, sir.
55, sir, answer.
Yes.
Angle AOB is also 55. Sir.
Yes. AOB. So these two are vertically opposite. That will be equal, but they're not asking AOB. They're asking OAB. That is different. Okay. Yeah. So this angle is 55. Now tell me, how do I find DCO?
Angle sum property.
Yes, very simple. Angle sum property. One of the angles is 70. This is 55. What will be the third angle?
55.
Okay. Is that clear, Tanushri?
Yes, sir.
And then to find this OAB, how do we do that? OAB. See this, in this triangle, this angle A is corresponding to which one? Look at the similarity condition. A is corresponding to C, right? O is O,
Yes, sir.
D is B, and C is A. So this angle A is actually angle C over here. So this has to be 55. You'll use the similarity condition. You'll say that corresponding part of the similar triangles.
PST.
Yes. CPST. Corresponding parts of similar triangles. Is it clear, Tanushri? All these three angles you will be able to find now?
Yes, sir.
They write it or you'll be able to do this?
No, sir, I can do it, sir.
Right. No problem. Fine. So
Thank
let's
you.
move on to this one. What is this? 6.36. This figure. QR by QS. Where is QR? QR by QS and QT by PR. Okay. And they're saying angle 1 is equal to angle 2. So try to understand where is this angle 1 and where is this angle 2 and what does that tell us? If this angle 1 is equal to 2, what happens? This becomes an
2.
isosceles triangle, right?
Yes, sir.
Since the base angles are equal, the sides opposite to equal angles will be equal. That means this PQ will be equal to PR. So now you will be able to replace this PR with PQ. Then the ratio will be complete, right? QR by QS is equal to QT by QT by QP. Then it will become your Thales theorem. You can subtract -1 and then whatever. Okay.
But can we use the similarity criterion, sir?
Oh, okay, okay. So you are in third chapter. No, I forgot actually. I have not taught you. That's why I forgot. I started using BPT over here. Okay. Yeah, that can also be done. We have to prove that this triangle PQS and PQR. Okay, these two triangles. So in this, what we know, angle 1 is already common, and then the corresponding sides are already in equal. Yeah, so it'll be SAS we can use, right?
Yes, sir.
We can use SAS condition, similarity. So if you have gone through that, then you should be able to know that. Okay. Otherwise, I was going to prove it using the BPT, and then I would have proved that all the angles are equal. Parallel, the PS will become parallel to TR, so all the corresponding angles will be equal. So I would have used that condition to prove the similarity. But since you have already gone through the criteria, so you can use SAS directly. Okay, it's better. So let's not do this. So up to here it will be same. There is no difference. You had to prove that the sides are in corresponding ratios. So what I'm going to do is to make the figure look better, I will draw the figure in which normal form, which you are normally used to of seeing. Okay. So let me draw the figure like this. So this is Q, R, and T, and the one which is parallel over here will be S and P. So let's say I have just tilted the triangle or made it straight. I have moved the triangle clockwise so that it becomes like this, straight. Everyone understands what I'm trying to do here?
Yes, sir.
I'm trying to move the triangle straight so that you are able to visualize that ratio thing, because if you should be able to do it in this form also, but if some of you who are not able to visualize like this, then for you I'm just doing that clockwise turning. So this side Q will be here, this R and T is over here, so this should be S and this should be P. And remember, PR is also connected, but I don't need this connected line, so I'm not going to draw it here to make it look easy for us to visualize. Okay. Now, see here, what is it we have got? We have got QR by QS is equal to QT by PQ, and then we already know this angle 1 is common in both the triangles, right? So this will become SAS condition. So how do you write it?
Sir, in triangle PQS and TQR.
Yes. So let's write it that way. Okay. Let's not write like this. So we don't even need this condition then, right? Or no, we need this one. We need PQ is equal to PR. We need that. Yeah. So write it in triangle. What are the names they have used? Let's use the same names, PQS. So PQS and TQR. Yeah. So what do we say? Corresponding sides should be in equal ratios, right?
Yes, sir.
So what was given? What is that angle? How should I write the name? Angle PQS is equal to angle TQR. What is the reason? They are common. So by SAS, Similarity Criteria. Triangle PQS is similar to triangle TQR. Is that how it would be right? Everyone is okay with this, guys? Confirm?
Yes, sir.
Okay. Tanushri, Hari, this was your question. Confirm quickly. Is it okay?
Yes, sir.
Yes, sir.
And any other questions? Okay, fine. So let me give you a question.
Like this, sir?
Similarity condition, based on the similarity condition.
Yes, sir.
See, this dot means multiplication, okay? This dot, what you see, it means multiplication. AP into AR is equal to AS into AQ. This is given to you. So you have to prove that.
Sir, figure, sir.
So since you people have done the previous question using SAS condition, see that this question can also be done using that, okay? That's why I'm giving you this question.
Completed, sir.
Okay, tell me, how did you solve it?
Sir, from triangle PAQ and triangle SAR, I took angle PAQ and SAR as equal, sir, because it is vertically opposite angles.
Yes, very good. These two angles are equal because they are vertically opposite angles. Excellent. What else? How did you get
And
sides?
from the given this thing, sir, AP into AR, I like transferred the AS to the left hand side and AR to the right hand side. So it will become AP by AS is equal to AQ by AR. So the sides are proportional.
Yes, absolutely
So
right.
by SES congruence, it is similar, sir. Then by CPST, I proved angle P is equal to angle S and angle Q is equal to angle R.
Yes, very good. That's good. Okay. So in triangle PAQ, see, before starting to write this, I would recommend you people to understand what ratios are given over here. Okay. Like we just now, Kavya said, these two angles are vertically opposite. So I have one of the angles are equal. I don't have any other angles given. So I will not be able to use the angle property. I have to use some other property, which is like, so if I have one angle, so you see there is something given like this. How can I use this to get the ratio of the sides? They are just product of the numbers, right? So AP into AR is equal to AS into AQ. So what I can do is, see here, where is AP? Look at this AP here. Now this AP by some other side, either this side or this side. Which side I can bring over here in the denominator? I have only AS and AQ. AS and AQ. So AQ belongs to the same triangle. So don't bring your AQ down over here below AP. Okay. Because AS is from the other triangle. That's why I'm bringing this AS down over here. So what I'm saying is write AP by AS, transpose this AC down this side. And then you see I have AQ. I have this AQ over here on the RHS. And I have AR over here in the LHS. So AR I can bring down over here to the right hand side. So it will become AQ by AR. Is everyone able to understand? There are so many other ways to write the same ratio, but this is the one you have to write. Why do you have to write like this? Because in the numerator, you want sides from the same triangle. So see, AP and AQ, they are from the same triangle. So I wrote them in numerator. Which triangle that is? That is PQA or PAQ. So this I have written in the numerator. Then sides from this triangle, I wrote it in the denominator, AS and AR. So,
Sir, then PQ is parallel to SR also, no? So they will be parallel, no?
Hold on. Let me see. This actually this angle over here, this angle is equal to this angle, and this angle is equal to this angle. Q is equal to R, because you see PA is corresponding to QS. So this P will be corresponding to S over here. So angle P is equal to S. Now tell me, is it parallel?
Yes, sir.
No, sir.
For it to be parallel, the alternate interior angles had to be equal. No, angle P had to be equal to angle R. Only then they will be parallel.
Okay, sir.
Okay, but here angle P is equal to angle S. So you should understand the difference. Some other problem like this, it may be like angle P will be equal to R. There it will become parallel, but not in this question.
Okay, sir.
Okay.
Just to understand.
Yes, that's okay. That is a good point. You have to understand it very clearly. It is parallel or not. Why is it not parallel? Through that question itself, you will be able to remember it. That why is this angle P equal to S only? Why not P is equal to R? Because we have taken the ratio AP by AS, right? So AP and AS are the corresponding sides. So P corresponds to S. That is why angle P will be equal to angle S. That is a point you have to understand very clearly. Tell me, all of you understand that point?
Yes, sir.
Yes, sir, I did not.
Okay. See, when we say that angles are similar in similar triangles, we have to take the corresponding sides and corresponding vertices, right?
Yes, sir.
So in this ratio, you have proved that AP by AS is equal to AQ by AR, correct? So AP from this triangle, this side AP, this AP side corresponds to which one? AS on the other side, right? This side. So these two sides are the corresponding sides. So A is the common vertex over here, and AP and AS are they are not equal in this case, but the ratio of these two sides are equal, means these two are the corresponding sides. So the corresponding vertices also will be P, and P corresponds to S, and A will correspond to A only. You see, this angle A is equal to this angle A over here. Same way, this side is corresponding to this one. So this vertex Q corresponds to this vertex R. Q and R are the corresponding vertices. That's why angle P will be equal to S and angle Q will be equal to R.
Yes, sir.
Okay. From the ratio itself, you can see this is A and A is common. See, P will be equal to S, only then they will be corresponding, right? P has to be equal to S. Same way, this A and A is common, Q has to be equal to R. All right, so yeah, so what I said that you should get this ratio before itself, so that you will be able to write the similarity ratio in the proper way. So PAQ how should I write what should be the name of the other triangle? Tell me. If I have written this one as PAQ, what should I?
SAR, triangle SAR.
Yes, instead of P I will write S. Instead of A I will write A. Instead of Q I should write R, SAR. So the order of these things are important, but not here. In this step you can write any name. It will not be wrong if you write any other name. Okay, there was not similarity over here. In triangle this and this is what. So in this step you can write any name, but I would recommend writing proper name from here itself. Okay, so that you don't have to do this again. There is no confusion. Yeah, so we have got the sides in the ratio. Then talk about the angle also. What is the angle? Let's call this as 1. PAQ is equal to SAR. Angle PAQ is equal to angle SAR. Why? Vertically opposite angles. So let's call this as second equation. So we can say from 1 and 2, we can say triangle PAQ SAR. Okay, so triangle PAQ is similar to SAR. What is the reason? By SAS. By SAS similarity criteria. Okay, and then just you will say by CPST, corresponding parts of similar triangles. Angle P is equal to angle. What did they ask us to prove? Here. P is equal to S and Q is equal to R. Just quickly tell me what are the similarity criteria you have learned, various similarity criteria.
AA, AAA, SAS.
Yes, yes, yes.
AAA, which we can also call it as AA. Both are same. Don't need to write all three angles. Even if two of them are equal, all the angles will be equal. Next one, SS.
SS.
So in this SSS, what happens? All the sides have to be equal.
In same proportion.
Yes, they have to be only in proportion. They don't have to be equal like congruence. Okay. So what that means is if you have triangles like, let's say this is A, B, C, this is P, Q, and R. So if the sides are in corresponding ratio, means AB by PQ is equal to AC by PR, and that third side is also corresponding sides are equal, that is BC by QR. All these three ratios are equal, only then we can use the SSS condition. This AAA is okay. AAA and AA everyone understands, right? Angles have to be corresponding, angles have to be equal. I hope I don't have to explain this one. Is it clear to all of you? First criteria?
Yes, sir.
Yes, sir.
Pragati, Ritesh?
Yes, sir.
Yes, sir.
Yeah. So any two angles, if you prove, you can just say that by AA criteria, the triangles will become similar. Okay, fine. So what is the third criteria you have learned?
SAS.
SAS. In this case, what has to happen? Whichever two sides you have in proper ratio. Let's say I'm saying AB and PQ. These two are in corresponding ratios, and AC and PR. If these two are in corresponding ratios, which angle has to be equal in this case?
Angle A is
Angle
equal
A.
to angle P.
Angle A has to be equal to angle P. Only then it will work. It should not be some other angle. Okay, the two sides and the angle between them. Same way, either it can be, it doesn't have to be only this one. It could have been AB, BC, and the angle between. It could have been PQ and QR and the angle between over here. Any one pair. Okay, side angle, side pair. Tell me, all of you understand that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, for example, I will write AB by PQ is equal to, let's say, BC by QR. Then tell me which angle has to be equal. AB by PQ, I'm saying, is equal to BC by QR. In that case, which angle has to be equal so that we can use SAS criteria?
Angle B equal to angle Q.
Yes, angle B has to be equal to Q. Everyone is able to understand that? So if these two conditions is there, then we can use SAS. How can we figure that out? You see, these AB and BC, they are from the same triangle, right? AB and BC. So what is the angle between those two? That will be your angle B. And then PQ and QR, they are from the other triangle, PQ and QR. And the angle between them is angle Q. And remember, anyone you can write in numerator or denominator, that doesn't matter. You can write PQ by AB and QR by BC also, it will be same thing. It doesn't matter which triangle you write first. But you have to be consistent. If you have taken this small triangle first, so you have to write AB and BC from the same triangle in the numerator. Don't write this one as AB by BQ and this one don't interchange by QR by BC. Okay, that will not be correct. Tell me if you understand what point I'm trying to make here. Same triangle, sides from the same triangle will be either in the numerator or denominator. So I have written this AB and BC in the numerator for this triangle, and PQ and QR from this triangle. Tell me, guys.
Yes.